mean an electromagnetic wave, right? Next slide, quantum of energy. That is the slide title. So we all know the basic physics law, E equal to h nu or hf. F is the frequency and E is energy. So based on this concept, as the frequency becomes high, the energy also is quite high. And of course, h is Planck's constant, which you know.
Sir, we are seeing only slide number 2, sir.
Slide number 2, energy equal to electron wave. Now I am in the slide, I think it should be number 4, quantum of energy. Is it?
No, sir. No, sir. We are in 2 topics of presentation. That slide is visible to us, sir.
So maybe then I should put that.
Maybe you can put slideshow and then move, sir. I think that should. Yeah, yes, it's moving, sir. Now it is in slide number 4, sir.
Now what is the slide? Slide number 3.
Basics electrons. Slide title,
Slide number
sir.
4.
Yes, sir.
Now,
Basics energy electron wave.
So this we have already seen. Have I explained this slide?
Yes, sir. Yes, sir.
Okay. So now I am in the next slide. Slide number 5. So this is what I have been doing now. Quantum of energy. So is that has it come? Slide number 5.
No, sir. It is in 4, sir. Energy equal to electron hyphen wave.
Has it come now?
Yes, sir. Now it is coming, sir.
I think maybe it's taking a delay. So in this slide, right, we have to recollect the quantum physics concept. E equal to h nu, where energy is equal to Planck's constant into frequency. So this states that electromagnetic waves are composed of packets of energy called photons. So at high frequencies, each photon has more energy. So photons of infrared, visible and high frequencies have enough energy to affect the vibrational, rotational states of molecules. Of course, if you go to the still higher range, X-rays, so that is able to penetrate our skin, right, for the medical applications. And the photons at radio wave, that is at lower frequency, at kilohertz and megahertz, they don't have much energy, so that they will not be able to remove electrons in the materials, right? So this concept tells us how the energy of an electromagnetic wave behaves at various frequencies. So now I am going to slide number 6. So is it visible?
Yes, sir. Yes, sir.
So here I am trying to show the electrons, right, in a conductor, right, and then how it behaves as a wave. So if you see this diagram, as we all know, conductor has a number of free electrons. So the motion of electron leads to current. And if there is a discontinuity, so there exists a field. And if the current is alternating, right, you get electric and magnetic fields. So if you see the first diagram on the left side, maybe you are able to see the cursor. So the electric field direction is top to bottom, and the magnetic field direction is anti-clockwise. Right? Now, in the next half cycle, an alternating current, the electric field changes its direction. It moves from bottom to top. So the magnetic field also, it moves in the clockwise, from anti-clockwise to clockwise direction it moves. So for every cycle, this direction changes, which is leading to the propagation of electromagnetic waves from a antenna or from any radiating structure.